Okay, visualizing domain and range. Right, visuals. Okay, we'll look at a graph. The domain, the set of inputs found on the horizontal axis, that's the x-axis. It's you reading from left to right on the x-axis, that's the domain of a graph, okay? The range, you reading the y's, okay? Functions outputs found on the vertical axis, the y-axis, that's you reading up and down the y-axis, okay? So if I look at this graph over here, this, like that. Now, this graph is not going down. This graph is going to the left and it's going to the right because I'm looking at the domain, I'm looking along the x-axis from left to right. So if I look at this down here, right? This must be going from negative infinity to positive infinity, and there it is, okay? There it right is there. I've underlined it. Negative infinity to positive infinity is the domain of this visually. The range of this, right? This is going down to negative infinity. It's going up as far as positive 4. So it comes from smallest to biggest from negative infinity to positive 4. And it includes the positive 4, okay? Again, over here. Look at this over here. Okay, there's the interval notation. Now set notation, okay? Which means it's less than 4, okay? Less than or equal to 4. Okay, but the actual range of this is negative infinity to positive 4. And remember, the domain was negative infinity to positive infinity. Reading on the x-axis for domain, y-axis for range. Let's have a look at this. Now, I did some of this earlier. So, have a look at this graph. Right. It starts here. A solid dot. It starts at negative 4 right here. Okay. So, negative 4 is where it starts. Where does it go to along the x-axis? It goes to 3. An open dot means it's not inclusive. So, use the parenthesis. So, bracket, parenthesis. Negative 4 to positive 3 is the domain. The range, let's read up and down. The smallest y I can see is this one over here. And that's at 2. Okay, there you go. Where does it go up to? It goes up to here, which is 5. And that's why that's the interval notation. It goes up from 2 to 5, interval notation. We also have the set notation here. Between negative 4 and positive 3, we can write it like that I've underlined. And over here for the range, okay, between 2 and 5, I can write it like this, okay. But there's the interval notation which we can tend to write it in, okay, for that particular graph. What's this coming up next? Okay, just graphs in general. All right, let's graph them and have a look. Now, do remember doing B. Have a look at B anyway, algebraically. Okay, remember, anything inside a square root must be greater than or equal to 0. If I take away a 4, x must be bigger or equal to negative 4. In other words, the domain is negative 4 to infinity. That's what we did algebraically. Let's have a look when we look at the graph. Okay, so this one here, I can't see any domains. Any domain restrictions here, any problems here? There's no denominators or square roots. I look at that and I think negative infinity to positive infinity, all real numbers. Again, look at B. I look at C and I go, I could put anything in there. There's no denominators or square roots. There is in D. So let's have a look at A, B, and C. Okay, visually. Here it is. Okay, look at the domain of A. Negative infinity to positive infinity. But look at the range as well. That's also negative infinity to positive infinity. Here it is. Okay, now then, let's jump over to C. Remember I said about C? Okay, look at this. No denominators, no square roots. I can do whatever I want there. Whatever I want. There it is. The domain, left to right, not up and down. Left to right, negative infinity to positive infinity. The range, up and down, negative infinity to positive infinity. How about B? Now remember, algebraically, I said, well, x's have to be bigger than negative 4. Anything less than negative 4 will make that inside the square root negative, and I can't square root negative. Let's have a look at it. And there it is. The domain, visually, okay, just visually, forget about the algebra. I can see it goes from negative 4 here, and goes on to infinity. Okay, so there it is. Now the range, now think about this, please. Negative 4 is an x value. The range, what's the smallest y? Well, the smallest y here is 0. Okay, there it is, 0, and it goes up. Keeps on going up to infinity. There it is. From 0 to infinity is the range. Again, visuals. The smallest y is 0, and it will keep going up. I know it's showing it going to the right, but it's going to go up forever as well. Okay. Right, let's have a look at some more on here. We also had things that had a rational, and these, again, there's a square root one, but that one, again, no denominator or square root. That one's probably all real numbers, but let's have a look at the visuals. Okay, remember here, x cannot be 2. X cannot be 2. Let's have a look at it. And here it is. So when you actually graph that, we'll be doing rationals graphing later. But can you see? That's what it looks like. But look, I'm going to put a line through here. At, guess where? At 2, because that graph cannot touch. Okay, I'm trying not to touch it, right? X cannot be 2. Actually, think of the visuals on this. What's the range? Right, so X cannot be 2. So I'll do that. X cannot be 2. But don't forget interval notation. There it is. Okay, from negative infinity to 2, 2 to infinity. There's the interval notation. Now look along here. Can you see the lines cannot touch y equals 0? The x-axis, remember, is y equals 0. So in other words, I can't have 0 for the range visually. There it is, interval notation. So if you look at this one, remember domain for this one, or I said for that one, where was it again? All real numbers. Okay, but let's have a look at it. Let's look at the range as well. Now look at that. Oh, the range, of course, looks like it starts at 4. Smallest number is 4. Negative 4, sorry. Negative 4 goes on to infinity. So there we go. The domain, all real numbers. Okay, left to right. But definitely the range starts at negative 4, goes up to infinity. Again, just visuals. The visuals on this. Now, if you look at that, you're going, the equation over here for this one. Visuals. If that's what it looks like, then look at this. The domain goes from 1 to 5. Can you see that? From 1 to 5, there it is. The range, smallest y is 0, and it looks like it goes as high as 2. And that's why that is the range. Okay?